In order to convince the engineering community that this particular control approach using dipole converter power architecture and the innovative group tracking uniform voltage distribution maximum power tracking control, I developed a prototype and actually built it. Recently, we have this prototype under testing. More test data, more detail, and implementation strategies will be presented in the Space Power Workshop next year. This chart provides you a confidence that all the simulation that we have done so far not only fully validated by the simulation, but the experimental prototype also confirm the validity of such control approach. The converter prototype have 3 power converter called dipole converter number 1, number 2, and number 3, and have the DC output port, and also have the 3 DC input port for power source number 1, power source number 2, and power source number 3. They also have 3 PCB that for 2 controllers. One controller for uniform voltage distribution controller that combine and work together with the output voltage regulation controller onto the same PCB board. The other controller board is called input voltage regulator and maximum power tracking. These 2 controllers combine to this PCB. Furthermore, the system and control have to work together. They need the housekeeping power supply. This is the DC to DC converter that provide plus minus 12 volts bias to these 2 control boards. Furthermore, we also have plus 5 volt regulator that accept plus 12 volts and convert this into 5 volt to bias the optocoupler interface that control their converters. In order to detect the power, the product between the voltage and current need to be computed by the MPT control. The send current resistor of 50 milliohm provide the method to send the currents to the maximum power tracking controller. One port is to inject the frequency disturb signal in order to perturb the MPT or maximum power tracking to operate efficiently. This 60 Hz signal can be provided by the utility grid voltage and step down by using the step down transformer. This chart shows the preliminary experimental result of the 3-channel dipole converter power system. The top curve in green color shows the power signal represent the total sourcing power from 3 power sources. And it can show that it can produce power at 450.8 watts, which is corresponding to the optimum peak power under uniform voltage distribution. Under this optimum power, the sourcing voltage V1, V2, V3 are equals and regulate at 41.8 volt, which is become optimum power voltage. In this maximum power tracking mode, it works even though the 3 sources are non-identical. To demonstrate the effectiveness of the maximum power tracking mode, we also do the testing when the maximum power tracking mode is disabled. And when the maximum power tracking is disabled, the sourcing voltage is collapsed to 23 volts and cause the significant loss of peak power. The power that delivered to the system is far below the system optimum peak power, which is only 277 watts. In this manner, we are able to demonstrate that when the MPT mode is disabled, we really cause the system sourcing voltage to collapse. This chart shows another preliminary experimental results. One in blue curves show the DC power versus voltage characteristic for 3 distributed power sources. In this system, test with the prototype, we have 2 linear power sources, which is resistive power source, and another 1 nonlinear power source, which is emulate the solar array characteristic. That is why the curve in blue is derived from the ideal parabolic curve, which have the discontinuity in its slope at around this point. Within the same test of prototype, the prototype also tests with the step load between 1 amp step load to 9.2 amp step load, causing the prototype to operate between regular output voltage regulation mode when the load is light, which is at 1 amp, and as soon as the load step to 9.28 amp, causing the system to change the control mode into maximum power tracking mode, and the peak power voltage is at around 40 volts, which is nearly 99.9% of power tracking efficiency is achieved with the prototype. As a result, in the non-maximum power tracking mode, the system operates in the regular output voltage regulation mode, and the system input voltage become much higher and approaching open circuit voltage. In this case, open circuit voltage of the system is about 71 volts, and under 1 amp load it only 67 volt DC. Finally, we need to conclude what has been presented so far. Optimum power tracking with uniform voltage distribution among distributed power sources has been validated through computer simulation for both power architectures, battery dominated bus or regulated voltage bus. Only one MPT controller is used to obtain a nearly ideal peak power with reduced component counts for each of control design and troubleshooting. Achieve maximum fault tolerance up to n-1 fault tolerance for n distributed power source. For power source of similar peak power voltages, despite their different peak powers. Thank you for your attention.